Hello, and thank you for joining us today for our webinar on Rehabilitation and Reline of Aging Structures presented by Contech. Before we start today's presentation, we would like to cover a few housekeeping matters that will ensure we have a smooth presentation. We have placed all phones on mute to cut down on background noise and to ensure everyone can hear the presentation. At the conclusion of today's webinar, we will provide information on how to obtain PDH certificates for today's presentation. The webinar is scheduled to last for 1 hour. We will have about 50 minutes of presentation followed by a question and answer period. When you logged on to the webinar, GoToWebinar window will have appeared on the upper right-hand corner of your screen. This window will minimize itself after a few moments so that it does not interfere with you viewing the webinar. If you would like to maximize this window, just click on the small red arrow and the window will be maximized. The blue box in the GoToWebinar window will allow you to minimize or maximize the presentation so you can view it in whatever size works best for you. If you have a question, please type your question into the question box at the right. We will be taking questions throughout the webinar and trying to answer as many as possible. Presenting today will be Hugh Mitchell and Don Herbert. Hugh is the Area Vice President for the South Central region of Contech and has been with the company for 27 years. Don is the Area Technical Manager for Contech's Southeast region and has been with the company for over 20 years. We'd like to start off today's presentation with a poll just to get a feel of who is in the audience today. If you could take a moment, what type of organization are you with? State DOT, municipality, parish, county, consulting engineer, or other? Hugh and Don, the votes are coming in, so it looks like I'm going to close the poll in a few seconds, and we'll be turning the presentation over to you shortly.
Great.
Thank you for voting. All right, it looks like we have 70% consulting engineers on the line, 14% municipalities, 9% state DOT, and 8% other. Hugh and Don, I'll let you guys take it away.
Okay, thank you, Lisa. This is Hugh Mitchell. Don is with me as well. We have had the great chance in our careers over the last 18 years or so up in New England to do a bunch of reline work. And it started with us in the mid-90s, and it got to the point by the late 90s where we were doing 25 to 30 challenging slip lining jobs a year up in the northeastern 10 states. And we've learned a lot of things. Since then, other folks in the industry have also developed some smart approaches. Of course, the CIPP approach has been around a while with in situ form. But today we're going to talk about the slip lining products that Contech offers. And we've tallied that up recently, and there are 12 families of products that we manufacture and represent that are great solutions for reline situations. The goal today is to share some of this knowledge and information and allow you to recognize where you might be able to go to get deeper answers when you're presented with a challenge on a drainage or sewer structure or a small bridge even that you're considering replacement or rehabilitation or slip lining. We'll talk about the advantages of relining. We'll talk about all the available solutions in those 12 families of products. We'll talk about Contech's design and construction philosophies and some of those considerations that we think are smart when you're looking at this type of project. We'll talk about some very specific projects of interest that will hopefully get your ideas and your mind flowing. And then finally we'll talk about what your resources are going forward. Throughout the presentation we'll have some polls. I think there are 5 of them that will allow us to ask some quick questions, and then we'll share those results with you just so you can see what your peers are thinking, that is the folks on this call. Structural replacement headaches are many. You folks on the call, 70% civils, significant municipal folks as well, and DOT folks. You guys know this way better than we do. Anytime you try to open cut a structure, it aside from being expensive and providing traffic headaches, there can be other issues with permitting, with the Corps, the schedule. Out in the Northeast, historic preservation is a big deal. So we're going to talk about those things, but again, you guys know that better than we do. We often get asked, what is the savings available of doing rehabilitation or relining versus open cut? You folks know better than we do, again, what the costs are for open cut replacement. We have a pretty good feel on what the costs are for slip lining. Generally, you know, the rule of thumb is hard to establish, but sometimes it's 10% of open cut costs, sometimes it might be half. But there are so many variables, you really have to look at each specific situation. A better piece of information that we can provide is the lower question, how much does a reline project cost? Well, that varies too quite a bit, but a good starting point is the slip lining material. And if you have a feel for what that material is, and of course you can get a quick estimate from a Contech sales engineer, if you take that number and multiply it by a typical range of 2.5 to 4, that usually covers you on a slip line. Now obviously there are some situations where it could be much less, and there are some situations where it could be much more. But what we've seen in our 18 years of experience is 2.5 to 4. The biggest and sometimes the most difficult to place a cost on, and certainly it's not a direct cost unless you actually perform an open cut solution, is the MOT issue. Maintenance of traffic, from my conversations with DOTs and agencies and civils, that's oftentimes the biggest headache to have to deal with, and of course it can be extremely expensive. With slip lining you avoid that. Some examples of real cost savings versus a conventional replacement. This was a Texas DOT job in 1993 where they saved $50,000 over a conventional bridge replacement. It's using an aluminum box culvert. This was a project within the last few years in Missouri that the DOT did, and it's really not an apples-to-apples comparison because they did the work themselves. Their cash outlay was $41,000 for pipe material. Their cash outlay for a piece of equipment and the precast boxes, twins, to demo and replace the existing concrete boxes was $379. So, you know, $338,000, but it's really not a clean analogy. This one also isn't a clean analogy. The engineer for this project for the New York State DOT estimated $2 million to replace this bridge. But to be fair and make it an apples comparison, the bridge replacement was $600,000. They ended up slip lining it with an aluminum structural plate super plate arch from Contech for $260,000. And that has all the costs rolled up into it in that number. The $2 million, the bulk of that was to support the historic buildings, the registered historic buildings that you can see in that photo. Nonetheless, it was a lot of money, even $260,000 versus $600,000. Here's how they did it. They first built an extended footing. They doweled into the existing stone arch footing, set reinforcing steel, poured concrete, and then placed an aluminum channel on top of it. From there, on the right side, lower corner, they built a platform and constructed 9 feet of structure at a time. And this was a 29-foot span aluminum structural plate arch. So they built 9 feet of structure at a time and then slid it in. And they simply used trailer winches mounted to the ends of the footings and did it by hand. The total pull for the final structure, which was 67 feet long, was 4,400 pounds. So aside from being phenomenally corrosion resistant, aluminum is a great slip lining product because of its light weight. This is a picture of the bridge maintenance engineer that was on site that day. He's sounding the structure during the grouting process. That's a great way to gauge where the grout is as you're bringing it up. And then this is the final product. Again, to be fair, they saved $340,000. But because of those buildings, it was technically $1.74 million. This is a project that Don and I were both involved with in the late 90s and 2000. It was a twin structural plate pipe under I-84 in Middlebury, Connecticut, and it had significant cover on it, so open cut replacement was going to be a challenge. You can tell by the white water, this is actually normal low-level flow. So you can tell it was an abrasion level 3 per FHWA guidelines. Frankly, if we would have known what we know today back in 1964, we would have put a 6-inch thick reinforced concrete paved invert in the lower 25%, and we wouldn't be talking about this structure today. Unfortunately, that didn't occur. It had significant corrosion in the invert that needed addressed, and because of the very challenging hydraulic situation, we had to go quite large and had to actually cut into the existing structure. The worst case scenario was we were removing structure from 11 o'clock around to 3 o'clock. It was done as an emergency declaration project, and also because of the hydraulic. Because of the hydraulic situation, they used shotcrete lining in the upper half of the structure, the upstream half. That was in order to keep the hydraulic grade line at the proper level. The lower stream half, because of the increase in velocity, they switched to aluminum tunnel liner plate, which could be left exposed and provide phenomenal service life, yet a high Manning's end to slow the water back down before it exited the structure. Total savings, they didn't estimate, other than on a napkin basically, what a replacement was going to cost, but we think it was $3.5 to $4 million from talking to the bridge engineer. Don?
Great. Thanks, Hugh. Thank you very much. I would like to touch on the topic now of condition of existing structure, looking for signs of an aging structure before it collapses. As you can see in that photo there, in some cases with the spalling concrete, you can get down to the cage of the cast-in-place or precast box, or in the case of other products, you might see situations where you have leaky joints of whether it be concrete pipe or metal pipes or clay or brick, as well as some potholes that may appear in the roadway. Just to give you an idea from the point of view of the range of products that Contech typically is involved in, whether it be culverts from 12 inches, even now with some new information I could explain, we can get a little smaller than that, through 20 feet. Then we also get into some mid-span bridges up to about 50 feet, and storm and sanitary sewers with a wide range from 15 inches up to about 12 feet in diameter. So when is it too late? You basically want to get to the culvert before you start to lose too much material around the actual structure, and you go from a round or circular pipe to losing some of its shape, and it gets out of ovality or it gets out of its original shape. That's when you've lost too much of the fill around there, and because of that restriction in area, it may increase the reline cost or reduce the number of options that you have. Here's a couple of photos again of projects where at this time it's a great application to Reline. You can see some of the photos where you have some exposed steel, whether it be a pipe or a box, or in the condition of the metal pipe products, you have a deterioration of the galvanized coating that's on the invert of the pipe, and depending on the situation, it could be 20 to 40% of the bottom of the pipe, but as you can see in that bottom right-hand photo, the rest of the pipe is in decent shape. These are times to get to these structures. You need to get to them before you lose too much of the steel or the backfill around it. Several DOTs out there basically state that relines are good up to about 25% of the metal loss on the invert. There are some additional supporting papers out there, either by FHWA or other sources, that I would suggest you contact your Contech sales engineer, and he'd be happy to direct you in that area. But again, you want to get to the structure to reline it before you lose its original shape or much of its original shape, and put a new product inside of it. What this chart shows, I know there's a fair amount of information on it, but it just shows the areas where Contech is involved in the reline and rehabilitation market. From the drainage market, again, from 12 inches through 144, and it goes through a variety of different products with A2 liner, which is a PVC pipe, a variety of different steel products, ultraflow with smooth manning coefficient inside, an 012, other metal products that are out there with different coatings that we'll discuss in a few minutes. We get into the sewer line and the sewer offering with A2 liner, Duramax, our steel reinforced polyethylene pipe, as well as an alliance that is very interesting, and a new alliance for Contech with the Sakasui products, where we're able to wind in place a variety of different shapes and different profiles from 6 inches to 120 inches for both the sanitary sewer as well as the drainage market. This opens up our portfolio and allows us to get into a lot of different areas that we couldn't before. And then as we move into the structures department, we have a variety of different products, some of which you already discussed, steel and aluminum plate products, as well as some of our bridge core, which is a heavy, deep corrugated product with steel, and then our conspans and bebos. And this segment of our business or rehabilitation is growing at a very rapid rate, and we'll show you some photos about that in a few minutes. I think it's time for a question, Lisa.
All right, let's go. Ladies and gentlemen in the audience, what Reline products have you used in the past 5 years? This is a multiple choice question, so you can select as many answers as you would like. CIPP, PVC pipe, HDPE pipe, CMP, or other materials. As we stated earlier, please don't forget to log your questions in on the right-hand side of the screen. We will be taking them throughout the presentation and delivering them to Hugh and Don so they can answer. We have a few more seconds on the voting. Not everyone has gotten their votes in, so I'll leave it open for a couple seconds, and then I'll turn it back to the guys. All right, we're looking good. I'll go ahead and share your results. Hugh and Don, I have 36% at the top with CIPP, 32% for HDPE, 23% for other, and CMP and PVC are tied at 17%.
Okay, great, great. Thank you very much for participating in that. I'd like to just give you an example and go through some of the information regarding the products. This is a couple of photos of our PVC liner, A2 liner. It is a direct bury product designed for the storm or sanitary sewer application. There is a lot of DOTs that are out there that accept this product, and one of the neat things about the product is that we've machined off the bell and allowed for a coupler to be put on it so that the OD of the product is uniform throughout the entire length of the pipe. We make the product for reline applications typically 12 through 36, and it has been used on quite a few different applications. The previous photos showed some jobs where we were aligning concrete pipe underneath an airport. That also goes to show, or Hugh will cover in a few minutes, areas where we can handle a variety of different loading conditions. The photos that you see here are, it's Duramax. Can you back up one, Hugh?
Sorry.
Okay. This is a Duramax. This is a steel reinforced polyethylene product. This is designed specifically for either low pressure or gravity applications. We make this product from 30 inches all the way up to 120. There's a variety of different couplers on this product, whether it be a low head 3 psi coupler, a 15 psi coupler, or a electrofusion coupler, which allows us to get up to 30 psi from a pressure point of view. It's a great product that allows us to reline both in the sanitary and the storm applications. Moving on with the pictures that are there right now. This is a picture of the metal pipe offerings that we have. And a lot of people might say something along the lines of metal pipe. In some cases, I'm replacing metal pipe. Why would I put another metal pipe in there? And the key point that I really want to get to on this slide is that the majority of the pipe that was put in the 50s and 60s was a galvanized product or an asphalt-coated galvanized product. Part of that was due to the speed that it was manufactured at and the cost. And it's only in the last 25 to 30 years have we learned a great deal of information regarding that product and its lifespan and durability. In fact, up until the 90s, CMP was the most heavily studied product, drainage product in the marketplace. But what I'm showing you there is products that have been developed over the last 50 to 75 years in which they have a more durable coating, such as aluminized steel, aluminum, or polymer coated. The polymer coating product is actually a FHWA Division 4 or Category 4 abrasion product. So it is an extremely durable product, and some recent studies out there give it the polymer coating an additional 80 years of life over a galvanized pipe. So the point that I would like to leave you with is that not all steel pipes are the same, and that there's several different coatings that are out there that if they were originally put in, you would not be relining those products today. This is an example of a polymer-coated double wall product with a Manning's end, so it's got a corrugated outside, smooth inside, great for large diameter relines. And this is a project where we're putting it in for 114-inch inside of a box culvert. Obviously, you have to make sure that that box culvert is sized large enough to handle the reduction in area, but it's a product that has actually, in this case, 4 layers of a polymer coating 10 mils thick. This is part of the new alliance that we have with the Sakasui products that gives us a broader range of rehabilitation products that we are very pleased to bring to you. It is a steel reinforced product, or SPR-PE, and it's a wind-in-place product for both the drainage and the stormwater market. We could range, depending on what product we use, from about 6 inches all the way up to about 120 inches in a wind-in-place application. This allows us to go from manhole to manhole and get this machinery into some tight locations, as well as some of the products are able to handle some internal bends as well as non-oval shapes or shapes that are slightly arched. So it's something that we are excited about and very interested in growing in the U.S. market. There is a lot of this product in the ground in Australia, Japan, and Germany, and a lot of this technology is moving to the United States, but has been tested and put in place for many years with miles of it in the ground for rehabilitation or, in some cases, direct bury applications. This just goes to show you that some of the people may ask, what's the pipes sticking out of the top? And those are one of the ways to grout a Reline product, where you slide the Reline inside the host, and then those vent tubes allow for the grout to go in as well as the air to come out. It's time for another question, Lisa.
Sounds good. How many Reline projects have you been involved with in the past 5 years? 0 to 5, 5 to 10, 10 to 15, 15 to 20, or greater than 20? The results are coming in a little bit faster for this one. So it looks like we are going to go ahead and give everybody a chance to vote and close the poll. Share the results. Don and Hugh, the overwhelming majority have said 0 to 5 with 87%. 5 to 10% said 7% said 5 to 10 projects, and 3% said 10 to 15 projects or 15 to 20 projects.
Okay, thanks, Lisa. Well, I think that makes it clear this technology and this approach is fairly new to many of us on the call, and we're going to now get into a little bit of discussion about design and construction approaches. Unfortunately, the AASHTO and AREA design specifications ARIMA, I apologize. The design specifications haven't caught up to this technology completely. There are many design product standards that ASTM has provided and AASHTO is also providing, but the design methodologies are still evolving. So you'll want to stay very close to your Contech sales engineer and his or her support team as you walk through this. But here's the philosophy. Hydraulically, we'll talk about that in a minute. Structurally, we take a certain approach that assumes the new structures are designed, or the relined structures are designed as if it's new construction. That provides a certain level of conservatism, but we think it's smart. We have some very strong guidance on service life, and then in a little bit we'll talk about construction practicalities. First of all, hydraulics. Most of the time, slip lining projects come down to hydraulic capacity and whether that's going to work or not. What we've found in our experience is somewhere in the 65 or 70% of the time range, there's a hydraulic option that will work. Occasionally, you know, it may be as simple as beveling the end in the event that a structure is operating in inlet control, or it could be as simple as providing a smooth interior structure versus a corrugated or rougher interior that was used as the original construction. There are lots of little tricks that you can do, and those of us on the phone that are hydraulics talented in the hydraulics field can appreciate this. This is a simple initial way to get a feel for it, assuming outlet control where Manning's in and hydraulic radius apply. It's not just an end area calculation like it is with an inlet control structure. What this gives you, the left is the original condition, the right is the new condition, and you can get a percent of capacity versus the original. This is a fancy version of the same thing. We can provide that for you. But again, 65, 70% of the time it seems there's a hydraulic option that will work with slip lining. Sometimes it will kick over. In fact, I got a call last week on a project in Louisiana under a railroad. The Corps is involved, and they want to slip line some culvert structures, 2 structures, but they don't provide enough capacity once the slip lining has occurred, so they're going to tunnel the 3rd structure. And that's a whole other topic area for discussion, but our methodology for that and our sweet spot, if you will, is less than 500 feet of length or so in the 4-foot to 15-foot diameter range. We provide an old standby approach called hand tunneling. And there are parts of the country that still thrive with that approach. It's a great approach, but other methodologies are obviously boring approaches and or jack and bore and auger boring, where you can jack a casing pipe or the finished product. From a structural design standpoint, I mentioned already, we assume normally as a starting point that the new structure carries the full load. Those loads are obviously highway loads, most common, but all of these structures can be designed for E-80 live loads, special military loads, and even heavy aircraft loads. We've even done some things recently with the large Russian jet. I can't remember the name of it, but it's heavier than a 747. We can provide you structural checks. Our mode is to support you as an engineer or an agency in your design efforts. We do provide design services where needed, where we can provide a sealed design for specific portions of the design, but obviously we don't have firsthand knowledge of the overall application and how it's being applied to your project, but we can provide product-specific analysis and structural design. We can even do some hydraulic checks for you. Next up on the design discussion is service life. Don mentioned earlier CMP. You know, I actually tried to find out a percentage of CMP that was in place since the turn of last century when it was developed that was galvanized steel. And the best estimate I got was 85%. That came from the National Corrugated Steel Pipe Association. So 85% of metal drainage structures installed since the turn of last century are galvanized steel. In most environments, that's a 25, 30, 35-year kind of service life. Now, in arid environments, it can provide 75 years or more. So it's all a matter of the environment that it's in. But there are other options, as Don mentioned, with aluminized, aluminum, polymer-coated, and some other options on corrugated metal pipe. So don't throw the baby out with the bathwater. Corrugated metal pipe has been used a lot, and there's very good reasons for it. You just have to use the right one using today's technologies. This gentleman in the picture is actually Larry Bednar. He's the father of aluminized, if you will. And this picture is from the 1990s. It's at the Genesee Expressway structures under an interstate south of Rochester. And he was checking it. It was a very aggressive, abrasion-wise site, low resistivities as well. And he's sitting in the galvanized structure, and you can see all the zinc is gone in the invert. The rest of it looks pretty good, so something's going on. The structure closest to you or toward the bottom is an aluminized segment, so it was done in tandem. And the aluminized section, if you take a what do you call it, a Brillo pad and rub off the black material, you find that it's simply an organic stain material that has adhered to the metal, and underneath it's brand new, clean, perfect aluminized steel. So it's dramatic, the difference that some of the better products can provide versus galvanized. Much of this is summarized in an FHWA report from 1991. From there, really, the research slowed down a great deal because we know everything there is to know. We've summarized all that knowledge on 2 pages in our CMP design guide. And based on a 2-year velocity and an assessment of the level of abrasion, you can assign an abrasion level per FHWA's criteria. That's the upper right-hand corner. Then you can go to the chart in the center, and based on whether you want a 25, 50, 75, or 100-year service life, you can select the right material. Then look up to the upper left-hand corner and make sure that your environment falls within the recommended range. And that environment, the easiest and cheapest way to do it is to take a pH and resistivity measurement of the soil and the low-level flow. Your Contech sales engineer can provide you great guidance on that. You can even do it yourself. We just bought another batch of hand meters. They're $132 for a pH and resistivity meter. Let's talk about construction practicalities.
Okay, Hugh, thank you very much. I'd like to cover that right now, but I just want to address some of the questions. There's a few questions that have come in regarding pipe arches and grouting, and we'll get to some of those in the next few slides. So hopefully I'll do a fair job in addressing those questions. But some of the common challenges, as Hugh mentioned, structural access, maintenance of traffic, and flow diversion. And we'll go through some of those areas right now with a kind of an example, walking through step-by-step of a project that we would work on. This is basically assuming that the next example is going to be for a full cross-section, basically what you might call a slip line for either a total circular product or a pipe arch or an ellipse. So for the people with the pipe arch questions, hopefully this will show you, yes, we can reline a pipe arch with another pipe arch. Many times the pipe arch that we're putting in there is a smaller one, but obviously the Manning's coefficient inside of it, because it's an ultraflow, is an 0.12 versus what could be an 0.23, 0.24 or higher Manning's coefficient. So even with the reduced area, we can still conduct the same flow in many cases. Well, what you see here is a situation where how would we go about a slip lining application, whether this is a metal pipe or a Duramax. We'd slide the pipe in. We may put runners on the bottom of the pipe to avoid the banging along the top of the corrugation, or to make it a little bit easier for less force to be put on the pipe to slide it in, depending on how far we have to go. Sometimes those rails could actually be mounted to the invert of the hose pipe. We'd advance the pipe forward. Then we would block it up in place. Now this is assuming in this application that we're able to get inside the pipe. So let's assume it could be 42-inch to 120-inch or 144-inch. It's large enough to get inside of it. Then you'd slide the next piece up to it. Again, you'd see the rails. You'd block it up. Once you mounted that pipe or you butted it up next to each other, you would then put on an internal expanding band. That internal expanding band is typically just designed to keep the grout out. Now, this could either be in a metal application, which I'll show you some photos in a minute. It's an internal gasketed band, but with the Duramax product, we're able to electrically fuse, or what we call put an EF coupler on, which allows us to hit a higher rate. In some irrigation projects, we have that pipe in there because we keep it from leaking, or it allows us to do rainwater harvesting tanks with a tighter joint. But in this case, it's let's assume it's a metal product, and then we would repeat the next couple of steps, advancing the pipe, putting the internal bands on, and then you'd be basically ready to grout the pipe in place. Or, excuse me, but before you grout it, you have to address the flotation and the buoyancy forces that will be on the pipe. So what you see there are vertical braces designed to pin the invert of the new pipe down, and it is pinning it down by pushing off of the roof of the hose pipe. This is one of the techniques that is used. There are several others between blocking or filling the pipe with water during the grouting process, but we have a lot of experience and can share that with you in regards to typically how you would address the flotation and buoyancy forces on a pipe when grouting. What you see there is another view, or an end view, of the brace, the vertical brace, getting down to some dunnage or wood on the bottom to keep from having a point load. And then we can put in grout ports at various locations within our pipe to address the different lift thicknesses that you would have on that pipe or that reline. Now, those lift thicknesses are greatly affected by the density of the grout, and we do cover and can cover with you some of the benefits of using a lightweight cellular grout. And we have several spreadsheets that we can run through and help you determine the lift thicknesses as well as the blocking or the bracing strategy, if that's the method the contractor chooses to hold the new pipe down in place. Here is an example of a project that I'd like to walk through. I'm sorry for that background noise. Here is an example of some of the of a real live job in Pennsylvania for State Road 30, and this is a case where it was an existing pipe arch, and it was needed to be relined. So they relined the pipe arch with an additional pipe arch while keeping the traffic open and redirecting the water. This was an aluminized Type 2 steel product that was used by Pennsylvania DOT, and based on, as Hugh mentioned, gauge or pH and resistivity, many DOTs like Pennsylvania, New York, and others give an aluminized, in Florida, to name a few, give aluminized steel in the right gauge and pH and resistivity 100-year service life. So they relined this product with a aluminized steel ultraflow product. You can see some photos of an internal expanding band in that case. The band is there strictly to keep the grout out from coming inside the pipe. You could also see at the bottom some of the adjusting rods that we can provide to create the new line and grade of the new pipe so that it does not just follow the hose pipe. In some cases, the deteriorated hose pipe may throw off your new line and grade. This is a picture of the bracing that you'd see on one of the typical relines, as well as the adjusting rods and the grout ports for that application. There were some questions about what type of grout to be used inside the annulus space. The key there, this is a good photo of what we're looking to use. The key is a very flowable grout, something that has a 9 or 10-inch slump. Many cases we would highly recommend a lightweight cellular grout, and we can assist you with different mix designs and information that typically a contractor would handle. But in this case, one of the things I'd like to point out is the fact that we strongly recommend a screen over the hopper in a relining process because you're trying to keep out the large particles or potential rocks that may be in the mix truck from its previous batch, because you don't want it to get stuck in the hose, which could cause backup pressure. The key is you want something that flows under very low pressure, so that you don't put a lot of pressure on the new Reline product or tend to move the new Reline product. Again, it's commonly done with a good grouting contractor. It's fairly straightforward. This is a good example of when I've spoken about lightweight or cellular grout. It's an ability to add a cellular foam to a standard cement water mix and not only increase the volume of the product but decrease the density of it, which again makes it more cost effective as well as putting a lot less pressure on the Reline pipe and a lot less flotation forces on it. This is back to that picture of SR30 in Pennsylvania. This is an example of the grouting process that is done. You can see the grout ports in different areas. Hugh mentioned or showed a picture earlier that many times during the grouting process the gentleman will sound the pipe or just tap on the wall. That's how they can determine where that lift is coming up the side of the pipe, whether it's plastic, metal, or steel. And what you see there, that white and red coupler, it's a quick shutoff valve. It allows the contractor to close off that ball valve to prevent the grout from coming in on them and contaminating any job site. So it's typically a very clean, neat, organized process for the grouting of the annulus space. And then here's the example of the finished product. Here's a pipe arch application, low cover over the top of the structure. And in many cases, this whole job was, I think, 168, 170 feet. It took about 8 days from the beginning when they cleaned the hose pipe, they relined it with the new product, and back grouted it. And within 8 working days, in this case, they were off that job while maintaining traffic, and really the public didn't even know they were down there working.
Thanks, Don. One of the questions we often get is how should you write up the specifications on these projects? What should it include? What should it exclude? And in the Northeast 10 states, as we developed this expertise, it was tempting for the agencies or specifiers to try to detail out and mimic our shop drawing submittal, which, by the way, looks something like this, but and try to show on their drawings the grout port layouts and get into great detail about the means and methods. We found that to be a mistake. The reason is the contractors that are bidding this type of work, some of them don't have a ton of experience, but some of them do. And we like to hold their hands through the process as they evaluate it and bid it, and give them guidance on all the variables that go into the decisions about how to approach the slip lining process and the grouting process. And if it's too defined in the specifications and the plans, then you don't get the creative thinking and you don't get the best cost or the best bid prices. So we like for folks to define the end result, the position and location, and of course to do all the upfront design work to determine if something's going to fit. Sometimes there are some specification requirements that put the burden of final fit up or final dimensions on the contractor, and that's fine. But what you don't want to do is detail out all the means and methods. Let them think creatively, and let them determine whether, for example, they want to grout something in 3 days versus 1 day, and then they can make the adjustments on grout buoyancy or fluid density and all those things. The end result is we walk through a number of things with the bidders on these jobs and offer them, we've been punched in the nose, if you will, on some things and learned some hard lessons. We like to share that experience so that things will go smoothly. Pre-construction meetings are very smart, and Contech can provide you with a generic specification that outlines all of the items that you would want to have a contractor submit for review and approval prior to construction proceeding. Lisa, how about a poll question?
Sounds good, Hugh. Let me launch it for the audience. How many drainage structures will be relined in your organization's jurisdiction in the next 12 months? select one below, 0 to 5, 5 to 10, 10 to 15, 15 to 20, or 20 and greater. I'll give you a few seconds to vote, but this is just a reminder that we are taking questions, so if you do have one for Don or Hugh, please log it into the questions box at the right, and we will be sure to follow up with you. Okay, I'm going to go ahead. Most people are finished voting and close the poll. Don and Hugh, the results are 78% of the audience have 0 to 5 projects, 10% of the audience has 5 to 10 projects, 5% of the audience have 10 to 15 or 20 and greater, and there are just a small handful with 15 to 20.
Okay, thank you, Lisa. Next, I want to show you a sampling of some Reline projects. You know, pictures always speak 1,000 words, so I'm going to supplement these photos with some background info as we walk through them. This is a Pensacola airport project. It was A2 liner. You've seen this picture earlier, but it was opened up in the center between a taxiway and runway so that they could access it and push it both directions. A2 liner has a constant OD across the joint. It makes a great slip line product. It is limited to 36-inch in diameter, though. This is a project in Wisconsin. It is an aluminized corrugated metal pipe inside of a box culvert. The reason I wanted to point this out, 144-inch diameter is the structural limitation of corrugated metal pipe until you get into bolted together plate products. The reason is flexibility factor or installation stiffness. The reason we were able to go higher on this, the final end condition factors of safety on corrugated metal pipe are quite large. And so we went bigger, which was lesser stiffness, because in a slip line application, if you do it a certain way, you can block the structure and deal with that lesser ring stiffness. This project in Ohio was interesting. Ohio has done 2 projects like this where they've gone in and built a tunnel liner plate new culvert structure around the outside of an existing structure and cut and removed that structure as they went. So it was really a partial tunneling technique or what some people would call a remining technique, and that can be done around a concrete or around a corrugated metal pipe structure, and it's a good way to increase capacity hydraulically. This was a Minnesota project where the tunnel liner plate sections, which again can be made in galvanized steel or aluminum, were placed down through a manhole lid and built down inside. This is one of my favorite personal projects just because it's at the Marble House in Newport, Rhode Island, which is a Vanderbilt home, and along the ocean front there. And they had a masonry tunnel that was deteriorating at 100 years of life, and we relined it with a horseshoe-shaped aluminum tunnel liner plate arch which can handle the sea air with no problem for a long, long time. This was actually the reline of 2 concrete arches that were built as part of the original Pennsylvania Turnpike section that connected Harrisburg and Pittsburgh. That opened in 1940 or 1941, and so the concrete arches had served quite well, but when they went to widen the I-70 with an additional lane, they wanted to extend the structures. They didn't want to have to deal with the MOT challenges that brought forward, and so they slip-lined the old structures with aluminum structural plate arches, and you can see they were extended as well. So the space between new and old was grouted, and the space outside of it was backfilled with crushed rock, conventional backfill material. This was one of the more challenging projects that we've done, and Don, you remember this one. This is under I-95 in Connecticut near Bridgeport, and it's a 13-foot diameter triple multiplate arch which had performed surprisingly well given it was a brackish water environment. It was slip-lined with 12-foot diameter aluminum structural plate, and we actually had to deflect the segments a bit to get through the tight sections under the high fill areas. But the savings to the Connecticut DOT was in the millions. This was a project where a new structure was built underneath a conventional bridge, and then the last step was removal of the superstructure and backfilling over the top and paving with a conventional pavement section over the top. So it was converting a bridge to essentially a large culvert. This was a project in British Columbia. So our friends to the north have tried Duramax already, and you can see by the size we can go all the way to 120 inch. And this too would be considered a slip line project, although obviously it's a bridge rehab situation. But our conspan shapes can be used to slide inside an existing structure, and the key to doing that is some of the hardware items that you use. You set the sections in on a concrete footing extension on rollers, and you pull them into place, and then you use a jack system to lift up at the angles that you see there to pull the rollers out and then place it back down in the slot. And then normal techniques take over from there with grouting and backfilling. Finally, before we summarize, and we're nearing the end, so it looks like we're in good shape to handle some questions at the end. This is a really nifty project in West Virginia, and it was actually bid out as a bridge replacement using conventional techniques for this 3-span structure. And the contractor submitted a value engineering proposal that offered the state significant savings, and this is what he built. So he used a 40-foot or 45-foot span Bebo twin leaf arch on footings, and he built that underneath the existing structure and began backfilling up to the bottom of the superstructure or the bottom of the piers, and at that point they stopped, dealt with the traffic MOT issues, but for a much shorter time frame, and then cut the pier caps off and continued backfilling and converted it to a buried structure versus a 3-span bridge. And $2.5 million is always a wonderful thing to put that back in the state's coffers. So I hope that you found the last 50 minutes or so before we get to some questions. I hope you found it very useful. We want to be a resource for you, whether you're a DOT, a municipal agency, a county, or a civil engineering firm working for any of those parties or others. We want to provide expert guidance for you. We have a host of experiences you've gotten a taste of today, and we can provide a number of resources for you, from helping you assess existing structures. We have ways to evaluate existing structures. We know quite a bit about load rating as well, but we can actually run the original structural calcs and put in lesser wall thicknesses, for example, and give you as-is safety factors so you can assess that. We can help you with hydraulic analysis. We can provide layout guidance. We can provide structural design support for you, and of course service life design guidance on existing or new.
Hugh, I'd just like to address some of the questions we have. One of the questions that came in asked why was there yellow paint on the exterior of CMP? Can you handle that question or address that, please?
Yes, thanks, Don. On an early picture, there was yellow exterior paint shown on an aluminum or an aluminized corrugated metal pipe. Some of the DOTs that are doing these projects regularly like to go ahead and use a zinc-rich yellow paint on the exterior, and what they use that for is to minimize the amount of, basically they cut it down to zero, the amount of aluminum consumption that occurs on the exterior wall during the hydration process for the grout. We don't think that it's really necessary, but obviously it's one more level of conservatism to provide that. So when they ask for it, we certainly provide that.
Great, Hugh. There's another question that was asked. How do you handle grouting around the liner pipe when you have a washout or there's an exposure of the host pipe? And I'd like to take that in the sense to say the solutions that Contech provides, all the ones that we've shown you so far, are direct bury solutions as well as reline solutions. So in some cases, some of the projects we've done, we've gone from a reline where you're inside of a host, you come out into a direct bury, and you can go back into the reline, back into the host. So in those cases, the product can handle that. But in some cases where we've had a washout, what we've done, if possible, is either, depending on where that is, if it's a cavity or a void around the hose pipe, you can, when you grout that, the grout will fill up that cavity or void, or we've recommended putting some native material back inside around that structure, carefully placing it in lifts around that structure, and then when you grout the void from the inside, it will fill in whatever areas you don't fill in with the conventional backfill solution. Each job's a little different. Again, you have to look at the hose pipe and determine whether it's partially deteriorated or fully deteriorated, and what type of stresses it may be able to handle. And again, as Hugh mentioned, your Contech sales engineer is a great resource, and they'd be happy to get out there and help you or address any of these questions based on your hose pipe and your existing conditions. But as Hugh already covered, there's a variety of different areas where Contech can give you assistance in your structural design, your service life guidance, your estimates, your specification support and pre-bid support, as well as we do have some technical installation guidelines that are available on our website for installing Duramax or installing CMP in or Ultraflow, or one of the corrugated metal pipe products, in a Reline application. So these are great sources and information, and if there is anybody after this webinar that would like to have a Contech representative come out to their site, please reach out to them. You can find out your local rep through our Contech website or calling the main office, and we would be happy to have that person address your questions in any way possible. I'm not sure if there's any other questions right now, Lisa, but that pretty much wraps up the presentation.
We did just get one more in right as you were finishing. How long do you have to typically wait between grout lifts?
That's a great question. What we recommend to folks is the prior grout lift simply needs to achieve initial set. You know, normally the structures are normally it involves multiple lifts, and of course with the grout mixes that we're most familiar with, you can get initial set anywhere from an hour to 3 hours from when it's placed. But the most important one is that first lift on a full cross-section structure, because that's where you cut off the buoyancy, the bigger part of the buoyancy equation. And we'll get into those discussions with you on specific projects. Every one of them is slightly different, but we can tackle those on specific items.
And in most cases, just through experience, 2 lifts, depending on how long the job is, 2 lifts a day is fairly common, but again, it depends on the job. Usually they're not many more than that, just from experience being out on a lot of projects.
And of course, with cellular grouting techniques, oftentimes you can, even on large structures, you can go with 1 lift because the buoyant forces it generates are much less than a conventional cement water-based mix.
Great. Thanks, guys. To the audience, thank you very much for your participation. This concludes our webinar for today. If you have any questions, please make sure you log them in right now. I won't close the webinar, so if you have anything last minute for Hugh and Don, I can send them out as soon as possible. Again, there will be a survey popping up when you close your webinar window, and it should pop up in your browser. If it doesn't, we understand. Sometimes if you're viewing on an iPad, iPhone, or other tablet, that this may not happen. We completely understand. And we want to thank you for participating, and have a great day.